I'm going to talk to you today about how technically we are building the IKEA knowledge graph. So you should be able to see my screen. This is a Medium article I wrote already 2 years ago. It's really just about how we structure the knowledge graph. And this is really important for also defining fair as well as now just data, because the importance lies on these top levels. So I'll send over the link to Deborah so you can have a look. It's called the IKEA's knowledge graph and why it has 3 layers. It's really based on this idea introduced by Dave McComb, which is that traditionally we separate the knowledge, anything in the semantic web to something called the T box and the A box. T box being the ontology, defining the central terminology, and then A box being all the instances that are created according to the ontology. So here is the ontology layer, and then here is the A box, the instance layer. However, in applied work in industries, as Dave McComb, who's been doing this now for over 20 years in industries through his company Semantic Arts, we have recognized that there's a very special layer of instances. And these instances are called categories. Within IKEA, these instances are actually things that our domain experts determine. This is where we store the information of the different kinds of colors, different kinds of product types, different kinds of styles, and different kinds of price levels. And technically, they're stored in SCOS vocabularies. They are called the control vocabulary, and these are the taxonomies. And what does that have to do with the provocation today? I wanted to give you an example of the power of these special instances. And I'm going to give it to you technically now with an ontology and taxonomy management tool that we are also using in IKEA. The reason why we like it is that it's visual. We get to edit ontologies visually, which helps us in democratizing knowledge management, ontology, and taxonomy management within IKEA. And so I sent you 2 instances of this tool called MetaFactory, and just this runs on RDF. So there are also other tools out there. This is not about like enforcing exactly this tool. This is one example of those tools that lets you edit ontologies and taxonomies in a visual way. However, good to know that that's also something we're using. And let's think about this one example that I find is really a good food for thought for just data. And that is the example of assigning a gender to a human. We know that, and I know from my past experience that in a lot of companies, you could, like in the past, only choose between 2 genders, woman or female or male, woman or man, etc. And that now with like right kind of movements and also understanding that not everybody identifies with these genders, we've also seen other categories, other gender definitions, or a non-binary, or I don't want to tell, options being given. But who manages these options? Who dictates the options? And actually just think about it on a large aspect. Somebody's giving you a drop-down list to categorize yourself. Who is in charge of that collectively? How do we create that? How do we create a consensus around it? And how can we make sure that we feel properly represented by these categories that are predefined? So let me create you an example ontology. I'm just going to call this like the human data ontology. And let's say this could be used for when we're collecting participant data. Maybe it's a participants to some medical test or examination, and we need to just document basic information about these humans. Yes, I'm just going to call it human data. I'm going to create an ontology from scratch just to give you an example. But I do encourage, if you are going to work on this, to look for different kind of ontologies like friend of a friend, FOAF, or schema.org, or others that make the case of defining human beings. So first, I'm going to create the class human, just to say that this is the one thing that we're defining. And then I'm going to think about what, I created my class. Then in order to collect information to a human, usually we have things like social security number, those. But let's just take first name, create first name as an attribute that we collect. This first name, one or many first names, one or many, actually, we're just going to call it, let's call it name. So one or many names that a human has in to their family name. And already now I'm taking into account that a human might have multiple names. So I'm saying that a human at least needs one name, but I'm not going to, so I'm setting the minimum count to one, but I'm not going to set a maximum because there could be many names there that a human has. And I mean, this is all discussions and depends really on much. And there's like, friend of a friend is doing a fairly good job on this, but there's quite a lot to align when we're adding these things. So that's the first attribute. Then I'm going to also set the second attribute. I'm going to add family name in here. The family name to a human. And maybe if somebody knows more about like how to describe family names, you can also like add more information. And here again, I'm going to set this to a minimum one, but we know that people might have many family names. So I'm also going to leave the maximum unbounded. And that's me describing for now a human in terms of like really basic information. Then if I want to assign gender, I'm not necessarily wanting to have it as a data type property. So data type property is here called attribute, and that is like a type of information, type of context and metadata that is attached to an instance which carries no identifiers. Names are really good examples of this because they shouldn't have an identifier. It should just be data about a person. Same goes for social security number. But when it comes to gender, we do want to give them identifiers because we want to make queries like, show me all the women that participated in this survey in June. So in order to then show me all the women, you want to refer to an identifier of woman, etc. or an identifier of identifying as female. So in order to create this information about the gender, we can create a new class called gender. Actually, just thinking maybe should be non-capitalized. There we go. And then we can assign something called the lateral connection. This is an object property, or called also as a relation. So a human has a relation to gender. And now we're going to call this. So we can call it something like identifying as has. So many times there's not a real so much hard science around what to call these relations or these object properties, but in IKEA we're using a convention that every triple, everything we create into the knowledge graph, every single sentence should at best read like a sentence. So a human identifies as a certain gender. And on the instance level, that will be Katariina Kari identifies as female. And that's like how, like, that's a strength of the knowledge graph, which recently we have also noticed due to large language models, because large language models can actually work with knowledge graph data better because it's closer to human language, because basically every triple in a knowledge graph reads like a sentence. So this is nowadays a kind of nice side effect of knowledge graphs. But that's why here I would use the relation identifying as confirm, and then that's the way I attach gender information to a human. Now we also, oh yes, and maybe we said that actually at this point there's only like this value should be 1 and 1 only. So we set the minimum and 1 to 1. Yes, let's save the progress, save the diagram. And now we have this information of human identifying as a certain gender. We can also add like other properties here. We could also be taking a viewpoint of this is not about identifying. We also want to collect, like maybe for a study on, I don't know, non-binary young people, something. We would also add the feature of was born as or identified as at birth as. So there's a certain choice you're making when you name your relation. Was born as is not necessarily what non-binary people think is a correct way of telling their original gender, but knowing that a doctor is usually someone who at birth assigns the gender, says this is a woman, this is a female, this is a male baby, that would be a more neutral way of saying it. So you could also mark this as was identified at birth as. So let's add that. Was identified at birth as, sorry. So there's quite a lot of like important decisions here to be made. And for this relation, maybe we're saying that, you know what, this is an optional information. Like our data set really doesn't force anyone to tell this assigned birth gender. So we're going to set the minimum count to 1 and the maximum count to 1. And these are, by the way, for those who know, these are shackle restrictions to this information. So here you can already see how we can bring like the way we talk about gender and the way we give people choices of giving their data, and we can give it a shape, we can give it a mandate. We can also like not put these restrictions of how much of this information is in there, but the more you do, the more similar kind of data, comparable data you have. But these are choices that also within IKEA, when we are shaping the knowledge graph, we need to make every day. And we need to align it with our experts and know exactly with which words, in which way do we want to represent our data. And if this is about judicious, unbiased, safe, and transparent, then I think these are also really important things. So it's not always like, I find in general, the semantic web community is not looking enough at the naming of object properties and the naming of data type properties. So I think that's one big important thing. And within IKEA, we've noticed that that's the one that actually holds quite a lot of information. And if we go to just modify the relation data, then what we can also do is we can give further longer descriptions. So here we can write, this is the gender that a human is currently identifying themselves as. So that's something we can add. And then if we add here description, this is the gender that's someone, and that's someone like a doctor assigned to this person on their earth. Some maybe of authority, there. So you can really spell these things out. You see here, I'm using this with the English lang tag, but you can also, there's also options to add more values here in different languages. It seems to be disabled for this free version that we're running, but it certainly exists in a full version. So you can also like annotate your data with different languages. Okay, so now we have an ontology that's been annotated. And now we're getting to the final part of my provocation, which is it's not only the relations, the attributes that matter and name things, it's also the options you give, or who decides what options do we have in a drop-down box for gender. So what we need to do next, I'm just making sure I'm saving my work, we need to go and manage vocabularies. So vocabularies, as you could also call controlled vocabulary, is something we create using the ontology. And these are controlled vocabulary or taxonomies. It's basically a list or a hierarchical list of terms to use. And these are all instances referring to my Medium article. These are things I call the middle layer, the categories. So I'm going to call this the gender vocabulary. And now my assertion is that who decides what these terms are? We know of female, we know of non-binary, but what else? And will this change in 100 years or in 1,000 years? Like, who knows it, and will this evolve? And what's the science behind determining a gender enumeration? So now I'm using this, since I'm really not the domain expert, I would need to consult the domain expert to properly author this taxonomy. But since I'm just an ontologist who's like kind of more having a layman's understanding of the field, I only have these three things. But that's what I'm leaving to you, is how would you actually find out the correct enumeration for this, and how would it evolve in the future? So these are the three terms to describe, and I'm going back to my human data ontology. And now for the gender, I'm going to add something that's called a vocabulary restriction. It says, by adding a vocabulary restriction to the class or relation to the class, we'll have a target value restriction to be on an instance of Scott's concept and constrained to a particular term, vocabulary or a term. So our term vocabulary currently is that of the gender. So I'm going to restrict by vocabulary, and then I'm going to look for the gender vocabulary. There we go. And now this has restricted. And how can this? Well, if I navigate to the resource, sorry, I'm going to open this into a new tab. If we're now going into just looking at human, we see here the schema usage description. We're seeing the family name, identifying as name, and identified at birth as. And we see that we have no instances yet of human. However, we can now enter a new term, and this term, this form for entering a new human has completely been dictated by all our previous definitions. So defining the ontology, and then defining the taxonomy. So here I will enter my family name. I will enter, and I will also add my second name in here. So now you know what my other name is. I'm going to say that I'm identifying as female. And I'm going to say that I was also identified at birth as female. And you can see that are obligatory, have a star in them. And you can add multiple choices. There is an add value button. You can also add a second term here. And all of this is steered from the ontology definition, the shackle definition, as well as the vocabulary definition. If you click here on the question mark, it will say the family name given to a human. So the description field we defined previously is now driving the explanation of this form. And all of this information is human-facing, or if you want, human-facing. And this is important for humans to also correctly add data. I'm going to save this entry. And now you know that, yeah, there just exists. I exist here as a human. And you can see that you can even browse this as a diagram. So if you have more entries, now there's only one, there's me. But if you add here more entries, kind of see which ones gather this female node and which ones would be gathering around this these other two nodes, which you can also find in the gender vocabulary. That's my provocation. How do you define vocabularies? How do you shape the overall data model for humans? And I hope that hopefully there's still some questions in the audience.
Katsi, I'm just going to say that Zoom is very good at blocking out the sound of applause. So it was heard in the room, but you may not have heard it at your end.
No, I was like quiet, and I was like, oh no, what did they think?
Yeah, we could try and do this.
It thinks of it as background noise, and so so mutes it. Yes. Did you want to? I have some things to say. So okay, so I'm going to counter provoke, and the organization of information, and not wishing to undermine anything that you said. The organization of information prioritizes the organization over the meaning. So, for instance, you were saying in 100 years' time, we might have other vocabularies for what the assignment of gender is. But in my thinking, we might have other understandings of assignments or of what genders or whether genders are to be. So the whole vocabulary is not just the terms that you put in the boxes, but it is the framework structure that you've put in there. There's a really good example of this. I was reviewing a European project that was about music heritage and music heritage using knowledge graphs. And what they were trying to do was, as part of this project, it wasn't the whole project, but as part of it, through knowledge graphs, they were trying to connect composers and musicians throughout history in order to identify some semblance of influence. Which seems like a very logical thing to do, and you know, you're very familiar with the classical music world, and so you know that when composer A meets composer B, there is some exchange of knowledge and so on. But what this resulted in was in a knowledge graph, I learned that Joni Mitchell had encountered David Crosby. Now, in my mind, it's like, that's not the story. There's a lot more to it than that. And what that means, this idea of an encounter, A, it's a really complex relationship of influence, and B, the story, and particularly the story of two human beings and what their relationship was both creatively and personally, is much more than that organization of information would suggest. So my counter provocation is not that we can open up the language by adding more terms at a later point, but that we are actually, by creating these relationships, restricting the possibility for information and meaning to occur in the first place. That was really what I was going to come to from that. So I'd be really interested in your response to that.
Yes, so with knowledge graphs, you cannot like 100% catch everything at the same time. So that we always say, don't boil the ocean. every ontology is one perspective on the world. That's why within IKEA, we have multiple ontologies, one for products and one for an interior designer's point of view of general products. So in the ontology for the products, table is a class, because then we have lots of different kind of tables that we're selling. But in the interior designer's ontology, table is an instance, and they're saying that a tablecloth is a really good addition to a table, a good accessory for a table. So they don't even care about the particular tables that we're selling. They're just saying in general, there's the general tablecloth. So there's a different level of granularity, just a different point of view. And what you need to do with knowledge graph is not boil the ocean, but choose an ontology that always takes one perspective. And then with these descriptions and with the human readable metadata, be truthful about that perspective. Be mindful of it. This is a perspective that's, you know, fit getting this idea in this context, but not this thing. And the best way to measure what would be a good perspective and what would be a good ontology is using something we call competency questions. Competency questions imagine that the knowledge graph is ready according to the ontology that yet to be designed, but it's already there. And it's like an oracle. You walk up the mountain, you meet the oracle, and then you ask any question and you should get all the replies. So you need to imagine what would be this knowledge graph that I'm building about, and what are the questions I would like to get answers to. And then you list all these questions, things like, show me all the people, like which humans, how many percentage of humans were assigned a different gender at birth than they now currently identify as. That would be a competency question that fits this ontology that I designed today. And so with these competency questions, you're first of all understanding the scope and the perspective you want to take, and then you design your ontology, and probably you should document to your ontology saying that this is something that's taking this particular perspective in this year, if it's also time-bound.
Thank you. Håkan.
Hi, Katariina. I'm Håkan. I'm from RISE. So before I'm going to ask some technical questions, and my background is I did my PhD on model-driven engineering. So I really like this, and it really resembles things I've seen before. So I was just thinking, can I have bi-directional relationships? Can I go from gender to human? Good.
Yes, you can, but then you would just give it a new relation.
Yeah.
So the knowledge graph on RDF is a named directed graph. The relations always have a direction.
Yeah.
So if you want to create an equivalent relation back, you first of all need to create a new identifier for it. It needs to have its new name, like female. How would it go? Female identifying as Katariina. So that would be something like female is the gender that that this person identifies, Katariina. So it's a bit of a clumsy example, but you would need to give it a different name because it doesn't work with the same name in the other direction.
Yeah.
Yeah.
But yeah, so the relationship would have a different name.
Yeah.
Good. Is it possible to have inheritance?
Yeah.
So a human could be part of a mammal, and then we could have dogs, and then we could assign gender to mammals, and then both humans and dogs would have gender.
Yes, that is exactly how the RDF works. I can actually.
Yeah. Is it possible to have unique identifiers, like not saying this relationship and all the long names, but just saying that's R1. And then we can have R2, which is the other relationship. And then we have C1, which is our first class, which happens to be named humans by us, but actually internally in the internal workings of this, we just call them C1, C2, C3, etc. And then we can all start automatically writing rules that enable us to transverse this knowledge graph and derive information from it.
So everything has an identifier in the knowledge graph. Mammal has the identifier here, IRI, is called Internationalized Resource Identifier. So that it's based on a standard, an RFSC standard. And you can see it's called ontologies.metafacts.com/human-data/mammal.
Okay.
So everything here has an identifier. Also, the instance of me that I created has an identifier. Nothing exists in the ontology or in the knowledge graph in RDF without identifiers. It's all based on it.
Thank you. So then here's my take on this. Now I understood it. So I'm going to say, if you want to put this in another context, you would call it a domain model, and you would go to the UML community to see all the things they've written about naming conventions and so on. And that takes
Maybe. I mean, the UML community is kind of old school, meant for relational database.
Very old.
Yeah,
It was
whereas this one
when
is,
it was thought
yeah.
of. Yes.
This is based on description logic, and this is also based on like knowledge management standards and best practices so far. So if you can use some of those naming conventions of the UML community if they're human facing, but if they're machine facing, you need to be aware of semantic web and RDF standard. So you need to know the standard to also know the machine one. And I have to say, when you create a UML diagram, it isn't like so machine readable. It's more like machine, maybe a little bit like computable, but it's not readable like RDF. So what this thing is creating immediately, if we, did I save all my changes? If we go to the ontologies and we look at this human data, you can actually see it directly as code. So it's already been serialized. I didn't just draw things. I actually composed an entire serialization that's now machine readable.
Yeah, and I can write a parser for this and do model transformation, so I can
You
generate.
don't need to write a parser. This is a very supported standard. You can use in Python RDFlib. You can use in Java Jena library, and in JavaScript, I think RDF4J. You don't need to write a parser for it.
So it proves two things. It's like the Swedish expression is a loved child has many names. So it's the same basic reasoning. It's just being packaged in very different ways. Yeah, you're laughing because we had this discussion about idioms and they're not carrying across language. I picked it up. I was not looking at you and you got it. Thank you. But it's a family of ways of doing things which has the same core in the background. I like that.
Yeah. But don't, like, one of the things that are heartbreaking when we see like people from other communities to come and reinventing the wheel of these like hierarchy and things inheriting. So do familiarize yourself. If you're working with knowledge graphs, do familiarize yourself with the resource description framework standard set by the W3C. This has also by Gartner, like Gartner was listing this summer, the top 10 data trends. And number 6 is RDF.
Yeah.
So this really is a framework that is taking everything you know about object-oriented data modeling and what you're mentioning about UML diagrams, etc. But this is like a standard that a lot of people have worked on. This is what Google's knowledge graph is based on, etc. The big ones.
Yeah. So it then comes back to Bock's quote from, I think it's 1920s, that all models are wrong, but some are useful. Which is exactly what you said. We need to define this so it fits our purpose. We want these questions to be answered, which is a very biased way of looking at the world, because we're deliberately going to exclude so many things and tailor it for our specific purpose and our understanding of what we are modeling.
Yeah. But you're not boiling the ocean. And if you're honest that you're taking this perspective,
yes,
that's the point. You need to be honest about it, need to be, like you are aware of it. And I wanted to show you here that if I now add this mammal in here.
I'm handing over the microphone now, but I'm still listening. Thank you.
Yeah, I'm showing that.
Thank you, Håkon. And just very, very quickly, Katsi, before you carry on, I just wanted to mention that the 3 years we worked on an ontology ecosystem, we had, for that very reason, a pluralistic approach where, for example, when we do competency questions, they are related to an application scenario. Application level, you build things according to the language that's used on the ground, and that you're responding to the needs of the application. You also have domain level ontologies that are then more generic and that capture some of the language and some of the relationships that are particular to that domain. We then started to align across domains because, of course, a product in one domain means something completely different from a product in another. Just that word it trips you up immediately. And we started to connect vertically to a top level where we have also a pluralistic approach, because the worldview at top level is based on different assumptions about how the world works. So, for example, we worked a lot with BFO, Basic Formal Ontology. Basic Formal Ontology is a US authored ontology that is used by US Defense, for example, but it came from the natural sciences, and it was based on some of the principles of the views of the world, which we could discuss at length. I mean, I said 3 years of discussions on that. Sorry, Katsi, to break into this. Just wanted to explain to Håkon that that's absolutely correct observation, and that was very much taken into account when looking at how we then create how do we then align across different worldviews?
Yes, I think I really like this way of working. I mean, I taught this for students. I think I've had 100-something student teams doing the same exercise, come up with a hotel reservation system and give me, I would call it the domain model, the ontology for that piece of software. And I didn't see the same model twice. So they always come up with unique ways of representing the problem of hotel reservations. But then of course, some biases was always there. These engineers, they don't have a diverse view of gender, for instance. And I think gender was rarely considered in their way of looking at the world. So again, you need to know what is in the system and what's going to be outside scope. But there's no one way of doing it. It's going to be a pluralistic way of modeling the world, depending on who you are and what you consider important.
Lots of people want to say, just ask Katsi, how is she doing for time? I just want to make sure, how are you doing for time? Because you wanted to say something.
I know that you are now having a conversation hour, but I have time for the next 19 minutes, like until past. So
just so that you're aware that also if she would like to also say something. So you were starting to say something and I interjected. Maybe we can go back to the comments.
Just wanted to add, so you kind of know what you can do here, is that indeed Håkon was asking about this subclass and things like that. So I could also say that there exists a superclass to human called mammal, out of which we can also have a subclass like dog. And we can say that every mammal is identified at birth as certain gender, female or male. And maybe here the vocabulary restriction would be different. It would maybe like, we could also work on saying that this thing needs to be actually according to only the biological genders, because there could also there's like non-binary is a more social concept. So there's a way to put into your gender vocabulary other terms and then create collections within. Just show you a bit of example. I can create here a collection, which is like, I don't know, biological genders. And then I'm adding here female and male only. There we go, save that. Then when I go back to my ontology model, sorry, here I will actually set this vocabulary restriction now to this property. So here I will restrict by collection, and it's called biological genders. I'm going to save this change to the ontology. I'm going to do one modification and move my vocabulary restriction over to this other relation, just to run this so I don't have like, what's it called, an inference happening or unclear instructions. And now when we again look at adding a new human, I don't know, let's add Eve from Paradise. So she is from here, Eve, or I don't know, like is currently identified as non-binary because she had it with the Garden of Eden and her dad, but she was born or created, molded out of, I don't know. I'm going here on a tangent, but as a female. And you can see that the same form still applies, but this information now comes from the fact that Eve is a mammal, or is like a subclass of a mammal, or humans are mammals, whereas this one is the social concept for humans. So all this works automatically. It's how the resource description framework is set up and defined, that subclasses and instances of a subclass inherit the attribute needs or the assigned attributes of the superclasses. I'm happy to take more questions.
So there were two people. Want to go first?
Two lighter notes. I reacted on this when it comes to the dog and gender, because I was starting to imagine how a dog identifying as a drag queen would look like. So that was one note. The second lighter note is that I think it was the Australian Army that used object-oriented programming and such in order to identify how infantry would fight or react on a helicopter landing of troops. And they thought that, okay, but the kangaroos are scattering very much away from the helicopter, so we can make a subclass of the kangaroos and use them as an infantry soldier. And they played that game very well. It was everything functioned. Yeah, everything functioned very well. The helicopter landed, the kangaroos, they were jumping all over the place in protection. But then they found out that the kangaroos came back with rocket launchers against the helicopters. So, so there's a danger with object-oriented programming and such. So just two light notes.
Yep. Yeah, there's actually what we're using within IKEA for the subsumption is a framework called OntoClean. So it looks at like with the rigidness of subsumption chains and identity as well as unity. And we're using them like as heuristics on checking if we're doing correct subsumptions. I wanted to show you here that indeed there's no like drag dogs that I'm aware of. So here currently to a dog, you would assign them a name and you would assign them a birth, a gender that's identified by birth. So that's how you change the model or like adjust it accordingly.
Yeah, the Australian here. I don't know how I follow that. I had more of an abstract discussion question. When we're talking about adapting, selecting the question for the data model, or selecting the data model for the question, it kind of raises this question about if I put this in the healthcare context, Europe is looking at creating a single data model for EHR systems, the hospital and medical record systems, which sounds like an incredibly ambitious, to my mind, and maybe even unachievable aspiration. The question or the comment that I've got is, there seems to be maybe a missing art or a missing socialization of the knowledge around deciding the optimal data model, deciding the optimal number of data models, systematizing the quality of building data models so that, that we can democratize that process. Simply having platforms for managing those data models and allowing you to, sort of select the right one to answer your question. So this is kind of a comment, but my question is, to me, this is, if we care about utilizing data, we need at scale to become more familiar with the challenges of doing that. And that needs to be open to more people. I'm kind of curious as to how we can approach this problem.
There's one thing about data models, which I think is so fascinating. Relational database world is like 100% dependent on data models. If you first, you need to create the logical and then later the physical data model, even to be able to input data into a relational database. Knowledge graph don't care. So an ontology can say one thing, but the data can be whatever. Nothing breaks, it's just triples. So the data model, this one that we're creating here, is really just a documentation on the data. And then it's also, because it has shackle, it's giving restrictions on the data. So now if you do have a database, or if you have put in, like, you have your data graph, so to say, the lowest level, all the data in its connected form, you can validate it and see if it's actually conforming to your model. So it's the other way around. You can put in data in whichever, it can be the wild, wild west. And then if you want to make sense to it or check if it's integrating with other systems, you can then start creating ontologies and shackle shapes to say, well, in order for this data to be complied with this and this system, it needs to pass these validation tests. And then you can say, okay, the data is today is not doing that. I'm going to do some integration, etc. Integration isn't as painful as it is with relational database. It's actually natural and second nature to knowledge graphs, because knowledge graph can have the same data expressed in different ways. We're seeing this all the time where, somebody has one model and, for example, the kinds of markets in which products are sold is an information that we store in two ways. One way saying this has been allocated this market at this point of the time, or another model needs to say this is currently been sold in this market. So that's two ways. One is to kind of overall say the end and start and end date for when this product is in that market. And the other one is about today telling you if it's in that market or not. And we have them side by side. One application needs that, the other one needs that. And all we're managing is the integration. We're saying that the one is the upstream information, the other one's the downstream information that we calculate in the knowledge graph daily. So that's the difference to relational database world. Data model is more like an advisory, and it's something you can work with, but it's not a restriction or anything that's actually disallowing data use or so. So it's also called the open world assumption. So I know it's crazy and most engineers get really frightened, but it's basically you can do anything.
Okay, Dubber, and then you have to remind me your name. Hannes. So Dubber and then Hannes.
Okay, without wishing to throw a spanner in the works and derail us slightly, I'm someone with a hammer who sees every problem as a nail. And so I'm approaching this from a media and cultural studies perspective and literary criticism, et cetera, but we're talking about language. So ontologies get you to models, which get you to protocols, which get you to conventions. And when you look at conventions from the perspective of semiotics, words can denote, they can connote, there are signifiers, there are signified, but what there aren't is objective realities. So you and I can agree on what a dog is because we use the word dog, but we have completely different things in our head when we say that. And so there is enough of a Venn diagram overlap in our understandings of that series of shapes on a page, which makes us think of the sound dog that we make, which makes us think of a specific instance of an animal that is more or less similar to the specific instance of an animal that you're thinking, or a platonic ideal of an animal. But when we say dog, we agree what dog means to a certain extent, but that doesn't mean that dog is true. That just means that there's a Venn diagram of understanding of overlap. So there is, yeah, and so the word can be useful, it can be validated, but we need to understand that it is a word and it isn't therefore true. And the same for that dog's gender. We can have an agreement of what we think that means, but it's just an idea. It's not a objective fact. But what I wanted to get to that is when we're doing the structure of knowledge, all we're doing is what we agree, what we think things mean. Language is just metaphor. And so what we're doing is we're stringing these metaphors together in a way that makes sense of the world to us. But I think we can get really bogged down in the idea of what things really are when there isn't a really. And I think so what we need to, step back from this is going, this is a way of describing an experience of the world. It isn't the world or even a map of the world. It's just a collective agreement about how we talk about things.
So you've just exposed directly the conflict that has been inside the ontology community from some of the authors in Italy who were, linked to the Umberto Eco Department of Philosophy, and who claim that there is, a logic that is unquestionable that drives this. And then huge arguments with others in other places who are having very different starting points in terms of how they map out how they see the world, which is why we went with a pluralistic approach. We also had to consolidate these different viewpoints at the very top level, and in terms of like what someone believes, if someone has deterministic beliefs in how you structure the world. Katsi is very well aware of this kind of debates. Maybe, Katsi, you can illuminate us a little bit about some of these interesting discussions.
Simply, and so during On the Commons, I also got to know Barry Smith. Thanks, Michaela, for the introduction. And we continued having email conversations about BFO. So BFO, for example, distinguishes between an object and an object aggregate. So an object is a complete thing, whereas an object aggregate is something that's compiled out of parts. And this is very central to IKEA. All that we need to assemble the customers need to assemble the products. So when these like assembly packages are coming to the customer, the packages themselves are objects. And when they have all the parts laid out on their floor, ready to be assembled, they are objects again, which then when they're assembling it and making the furniture the furniture becomes an object aggregate. But since they're also moving that thing in their living room, placing it to some other place, it's again an object. So something like an IKEA product can be at the same time object and object aggregate. So there is no one class out of which that comes from. There's just a perspective of in a certain time it's an object aggregate, in this other, like when they're complaining to customer care that something went wrong with the assembly, then it's probably an object aggregate that we're looking at the different parts. But when they're moving it around in their living room, it's an object. So at any point in time, there is no absolute truth. It's we cannot divide the world into one ontology layer and one instance layer, but they're just different viewpoints. I'm seeing hands moving, but I'm not hearing.
No, I was waiting. Yep. No, I think regarding some of these questions, it's good to keep in mind that often when we build and work with knowledge graph, we often operate under the open world assumption, as you mentioned, that I would describe is rather that the assumption that the knowledge graph we use are incomplete. If all known fact were in the knowledge graph, it would be the closed world assumption that the knowledge graph contain all the truths. But for instance, if the node or class Hannes, the relation is born in Sweden, exists in the graph, or rather does not exist in the graph, that would mean that we don't know whether or not I was born in Sweden. So to keep the mind open to say that we work with an incomplete graph that might lack information, if that makes sense, to always keep that in mind, because that explains some part of it.
Open world assumption is very interesting, very frightening for engineers. Hannes can be, some is saying fact that Hannes is born in Sweden and Hannes is born in, maybe you're born in a town And then if born in it should be only one, or that it's the same thing, then the town and now the country become the same thing. So there's also like these description logic pitfalls that you can find if you're making too powerful reasoning on top of incomplete knowledge graphs, as you're saying, because they operate on the open world assumption.
Comments? Guys?
Really good discussion. I'm so happy about.
Yeah, oh,
all the
absolutely.
questions.
Thank you. That's
Yeah.
been amazing. And let me just see. So you have literally, I'm just trying to see if, you have 1 minute because you said you had to go at 14:30. So maybe what I will do is I will inform our colleagues here about some of the work that happened last year. And I think that's also very interesting in the sort of effects that you can have from implementing knowledge graphs in the way that you have done in IKEA, because I expect that you don't have enough time to kind of tell us a little bit about that. It's a bit late.
Yeah, I guess, I mean, there was a whole presentation around it, so it's
yeah. So it's better if I just
yeah.
explain it and don't put you under pressure now in the last minute. But basically, yeah, I mean, we are talking knowledge graphs, so we're not talking knowledge representation. So some of the comments that were, how do we know what kind of knowledge representation to go for? Well, I would say, in very kind of rudimentary terms, you ask yourself, if you have a problem in everyday life, what sort of knowledge field do I need to consult in order to solve this problem? So you have options of different ontologies, different domain ontologies, different application use cases, different knowledge graphs that are designed for particular application use cases, etc. And therefore, there isn't a one point of reference. You have to choose the correct point of reference or build the correct reference documentation for what it is that you need. And I would say that is directly comparable to how we manage knowledge in everyday life. I don't know if I'm wrong in that, Katariina. Would that be fair to say?
Yeah, it is totally like fair to say in this way. But there is maybe one more design principle that I would like to convey here is that we do also mostly design our ontologies snug to a use case, but not too snug, and trying to kind of anticipate a future life for this ontology, and also to understand that ontologies do evolve with time. So those, like, we try to make it snug but still future proof, so to say, and it's a bit of a balance to strike.
Of course, there is an expertise and an art in what you do as an ontologist. There's no question about that. So this has been, I hope, very informative. We can actually carry on discussing this for a few more minutes here because we still have a little bit of time before our coffee break. But in the meantime, I don't want to hold Katariina any further because she took time out from her work, from her job to be able to be with us. So we are super grateful for this. Hugely insightful. Everybody's nodding. Everybody's super happy. So a round of applause. I will keep my mic on so you can hear.